Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm going to be trying to finish up this project working on the vise that I had a viewer and friend bring to me. We've already made a new screw for that vise, but he also brought along some new jaws that came off of these. Are removable jaws, and they're in pretty rough shape, and he'd like to get a new set of these made as well. So we're going to do that. I have got some A2 tool steel here. This is some air hardening tool steel, and I did a quick check. I don't know exactly what material this stuff was made out of, but it's hard, relatively hard. I did use a little hardness tester that I've got. Mine is not a super accurate hardness tester. It kind of gives you in a range, but the Rockwell hardness on this on the C scale is between 45 and 50, which is definitely in the range that we can harden this tool steel to. A little on the soft side for tool steel. It's on the hard side for mild steel, but we will be able to harden this. I think when you harden A2, it goes up to, what is it, Rockwell 60, 65, somewhere in that range. But then you can temper it back down to a lower hardness, and that's what we'll plan on doing. I just bought some tool steel. This is, I think I got this from McMaster-Carr. And but we're going to have to do some milling and machining to it to get it where it needs to be. Let's zoom in here, show you what we got to start with, and get to work making some new jaws. So this is the original jaw that came off of there. 3 countersunk screws holding it in. There's a slot in the back. Let's see what the dimensions are on that. So it looks like it's 1 inch, 435 thousandths wide, 610. Varies somewhat depending. I'm gonna call it 625, which is 5/8 inch thick, and the length on this is pretty tough to get an exact measurement. I'm just gonna call it 5 inches. I think that's what it was, but you can see it's been beat on and broken them up, what have you. There's a groove in the back where that fits up on the jaws, and that is 640 thousandths wide. Probably had a 5/8 inch slot that fits up on with a little bit of a play in it, and it's about 340 thousandths deep. So to make this out of, I got some 5/8 inch thick by 1.5 inch wide tool steel. So looks like we need to, depending on where you measure it at, it's real close to 1.5 inches. I bet this was 1.5 inches, but you can see that's been pretty chewed up and ground on the top. We might just leave it like it is and go with it. Let's see, 380. Yeah, I'm sure that was, I'm sure that thickness was the same on both sides originally. So I think we can just go with the stock material here. We just need to mill that slot in the back. Let me open that up. So when you order this stuff, it usually comes sealed up in this little protective coating. This is just some paper that's kind of wax coated on the inside. It just keeps the oxidation down on it, keeps it from rusting basically. And this is in its annealed state, so it's on the soft side. So I think what we're going to do is I'm going to go ahead and we're going to just prep this whole blank. So, and I think I'm going to leave the thickness like it is. Like I said, the width is a little bit narrow, but I'm pretty sure that was the original width, and it just has worn down on the top. So we're going to go with that, and we're going to take this to the mill and cut that slot all the way down this entire piece, and then we will do our serration on here. I'll probably do that over on the horizontal milling machine. We'll drill these out and we'll cut them to length once I kind of get everything done. It'll be easier to do it all in one piece and then cut the pieces out of it. That's the game plan. Let's get over here and see if we can get this knocked out. I think I've decided I'm going to do that slotting over here on the horizontal milling machine. I've got a cutter I think that's going to work good for it. So first things first, I want to make sure this vise is trammed in good. I think I trammed it last time I used it, but don't remember. Want to make sure So I'm gonna fire the machine up. I've got a stare at last word indicator in there, which is one of my favorite indicators for tramming like this. What I'm gonna do is I'm gonna move my vise down to the end here, and we will bring the table in to the indicator and put it on 0. Now what we'll do is just use our rapids. A lot of times when I first do that first bump, it's gonna bump, so I'll probably stop and re-zero it. Actually, it didn't. And that vise is looking pretty darn good. You know, I'm within 1/1000ths from end to end. We're probably gonna leave well enough alone here and just roll with it. Yeah, it's within 1/1000. I'm good with that. All right, let's get our cutter set up over here. So my mill machine is a Kearney and Trecker model 3H, and we got a 50 taper spindle here that I'm going to put a arbor in. This is a 1.25" arbor, 1.25" diameter, and we'll just put that in there. There's a drawbar over on the back side of the machine. It's basically just a threaded stud. You tighten that up, it draws that in and tightens it in there. So, all right, I got it engaged, and now I'm drawing it tight. I'll just use a wrench back here on the nut, and that is firmly affixed. I'm going to put some spacers on this arbor to get my cutter out here roughly in the middle of the arbor where I want it to be. That's the nut that tightens and loosens everything. These are just spacers. I'm just going to put a few on here. Different size. All right, that's roughly halfway through. All right, there is a key way on here. I want to get that key in there. It's going to drive the cutter. So I got that placed. And this is the cutter we're going to use. This cutter is, I found it over in my drawer. It had been reground. It was originally 5/8 inch wide, but it's narrow, a little bit narrower than that now. But the main reason I'm using it is 2 reasons. Number one, it's a skip tooth pattern. You got a 2 tapered teeth on there that alternate back and forth. I just find those cut better, particularly on deep cuts. And what we'll do is we'll make 2 passes. We'll get 1 pass in there, and then because it's not exactly 5/8 of an inch thick wide, it's a little bit over anyway, I'm gonna have to move the cutter over, make another pass to finish cleaning it up. So anyway, we'll put that in there like that. And let's get some more spacers on here. We're gonna put another spacer here. There we go. And then my bearing will go on. Let's see, I need a little bit shorter, little thin spacer right there. Let's try that spacer. Put our bearing back on the end, and then we'll tighten this up here with the nut. And I'm just going to finger tight it right now. I'll tighten that up once I get the support on it so that I'm not bending this shaft, putting a lot of force on it. I need that support on the end. I'm going to bring my overarm support back out. It has the arbor support on the end, and I'm going to level these out. All right. Pull this support off, and it's actually on there backwards. It probably doesn't matter. There's an oil reservoir and sight gauge on the front that's Nice to be able to see, but it'll work either way. There we go. Just get that on there, and we'll tighten the nut up on the top. That'll lock it on these arms. Once I get the arbor support mounted up here, tightened up, I'll pull it up onto the bearing. Now guys, one thing that I've learned is it's a lot easier to get this thing on these two top pieces and just get on there first and then pull it up onto the bearing rather than trying to get all three lined up at one time. Getting all that stuff lined up just right can be difficult. Once you get it lined up on the overarm supports though, we can come back here and just pull that right up on there, and it just goes up on nice and easy. And I'm gonna go ahead and lock these overarm supports. There's some bolts up on the top of the machine that tighten them up so they can't move in and out. And that is done. All right. Once everything is on here, we'll go ahead and tighten our nut up. Don't forget to do this, but again, I like to do that when I have this support on here. Otherwise, because this arbor is so long, you got a lot of torque on there. If I go wrenching down on that, I could bend that arbor. This way it's supported right there where I'm tightening it, and everything's good, but you gotta remember to do that last step or you'll get yourself in trouble. There's an oil reservoir built right into this arbor support, and I'm gonna make sure we get some oil in there. So there's a little plug right here you can unscrew, and you can see a little sight glass here, and that right there will tell you that oil should start filtering down in there. Here it comes, and you just put it in there. Make sure you got some oil, and what this will do is it'll just drip down onto this little bronze bearing and make sure it stays lubricated while you're using it. That should be plenty of oil. Seal that back up. All right. I'm gonna get my stock in here. I've got this big heavy duty vise here that's gonna do a good job holding this longer part. And what I'm gonna do is I'm gonna put a couple of 1, 2, 3 blocks down in the bottom of the vise. And we're just gonna set our piece of tool steel in here. And it's gonna be supported pretty well from end to end, which I like a lot. And we'll tighten this up. That should hold that real good. All right. So next thing I want to do is I want to get my cutter positioned where it needs to cut. And what I've done is I've come in here and I've just bumped up one of the cutter teeth to the edge of this vise. Nothing's turning. I just bumped it up there to it until I could see it, feel it stop. And that's going to be my 0. And for what I'm doing, that's going to be plenty accurate enough, guys. I measured the original one here, and it is exactly 3/8 of an inch from the edge over in the center of this. But from one end to the other, it varies about 10 thousandths of an inch. So I know that we're plenty accurate. We got at least a plus or minus 10 thousandths tolerance here, or plus minus 5 thousandths tolerance based off the original part. So what I'm going to do now is I got an indicator mounted on the vise touching the cutter. We're going to move it over 3/8 of an inch, 375 thousandths. So we'll just come in here. That's 100, 200, 300, and 75 right there. I'll lock my table down and double check, make sure it didn't move. It didn't. So we should be, the edge of this cutter should be 3/8 of an inch from the edge of the stock, or within a thou or two, which will be plenty good enough. Next, we need to do our depth of cut. And what we'll do is we'll touch off on that. I think what I'm going to do is do my depth in 2 passes. We'll do half of it and then come back and make a second cut for the second pass. And 2 reasons. Number one, I just don't know how well this cutter is going to cut in this tool steel. I don't want to try to hog off too much in one pass. More than likely, this horizontal milling machine would easily cut that. But the second reason is that after I make that first pass, I can get a really accurate depth measurement and then dial in the final depth after that. So, all right, let's get the indicator out of here. We'll be using it again in a minute to get our depth. But first thing we need to do is touch off on our work. Thing I want to do is figure out the RPMs I need to be running on this part, and I'm going to use this little K&T chip volume speed and feed calculator. It's a little slide rule type tool, real handy. I use this thing all the time when I'm setting my machine up. So first off, I know I've got a 5-inch cutter. So what I've done is I've got my cutter diameter. I've set it right here on the arrow where it's on 5. The next thing I need to do is figure out what my surface speed and feet per minute needs to be. And there is a cheat sheet on the back here. And you look on there and determine what type of material that you're cutting. We're cutting steel. And even though this tool steel is in the annealed state, I'm still going to call it hard. I'm going to be conservative, and you look and see what kind of cutter. I'm using a high-speed steel cutter, so it's recommending a speed in feet per minute between 30 and 50 feet per minute. We'll flip this back over. On the bottom scale here, we have feet per minute in between 30 and 50, and you can read on here what your RPM range is. So I'm just going to say between 25 and 40 RPM is what we need to be turning that cutter over there. And I've already looked, I've got it set on 26 RPM, which is again, a little on the conservative side. I could go just a little bit faster, but seeing how this is not a production job, we're not in a race, I would rather be a little bit on the conservative side than trying to mess a cutter up, burn a cutter up or something like that. So anyway, there you go, the Kearney Trekker chip volume speed and feed calculator. It'll also can use it to determine your feed rate. We look over here, it also tells us the feed per tooth rate is 3 thousandths to 10 thousandths. So again, I can look over here, I can look on my RPM, my number of teeth in the cutter. There's 10 teeth on each side. There's actually 20 teeth, but there's 10 on each side. So again, be conservative. I'm gonna go on the conservative side. I'm gonna take my 10 and I'm gonna put it on 26. And this tells me my feed in inches per minute that we need to be running. And I look at my feed per tooth, which was what, 3 to 10 thousandths? Yeah, 3 to 10 thousandths. So I'll look down here, 3 to 10, it needs to be somewhere in this range. So it looks like between 1 and 2 inches per minute needs to be my feed rate that I'm going to use. And I'll get that set here in just a minute. So I've got my speeds and feeds all set. We're going to go with 1 1/8 inch per minute on the feed rate, again on the conservative side. I want to touch my tool off here to get a depth cut. So I'm just going to turn everything on here and we're going to slowly raise this table up until I see a chip come off of it. All right, I see it just barely touching in a couple places right there. So I'm gonna go ahead now and pull my cutter off the end of the part. The depth of the original here is 350 thousandths. Like I said before, I'm gonna do this in 2 equal passes. So it's 175 thousandths is gonna be the depth I wanna dial in. I've got a dial indicator again. We're measuring off of a fixed measurement here, the same height as the cutter, overarm supports, everything's rigid here, so it's the same. And we're going to raise the vise up 175 thousandths. So we'll come around, that's 100, and get over here where I can see it. There's 75 right there. And again, we'll lock our table, and I think we are ready to make our first cut. Let me get this indicator out of the way. All right guys, ideally we would be using flood coolant on this. I really don't have flood coolant set up on this machine, so I do have a mister here. It's just going to be putting mist on there. That'll help keep the tool cool and get a little lubrication in there at the same time. So we'll turn everything on here. Engage our feed and let's see what happens. All right, we are making contact. And it is starting to cut. As is usual with these horizontal mills, it tends to want to cut more on one side than the other. But I think we'll be fine. I'm going to turn that mist down just a little bit. Appears to be cutting just fine though. All right, we're just gonna let her cut on through here. Nice, slow and easy. I'm forming a nice chip. I'm kind of touching the bottom of this shaft over here, or the piece of work. And it's warm, but it's not super hot. I think we're gonna be all right. Let me get a little bit more mist on there. All right, this is cutting at 1 1/8 inch per minute, so it's going to take about 10 minutes or so to cut across this part. So we'll bring you back here in a bit and let you take a look at it. It's just going to slowly cut that material away. Everything looks good so far. Yeah, my part's nice and cool. I increased that mist a little bit and it's cooled down considerably. So I'm happy with where we're at. We're gonna let her cut. We are approaching the end of our cut here. We're gonna let it just come right on out. And I think when we get done with this, we're gonna go back and dial in the second half of that cut, which will take us down to the 350,000 step. And then we'll scoot over and cut out that little thin section next to it to get it to the proper width as a final pass. And this is cutting fine. I think it would have very easily had done the entire depth in one pass without any problem at all. But I always, first shot doing these things, I'm always trying to be a little bit on the conservative side. Don't want to mess anything up. Again, this was a production job. I think we could have custom ordered a cutter to the correct width and just plow through these things, probably faster RPMs, faster feed rates, everything, and been fine. But we're going to take her slow and easy. All right, we are past the center of the shaft. I am going to cut back through this. And we'll get our indicator set up, go to our final depth, and one more pass. Looks like we're wrapping up this cut. It's about to come out the end there. And went just like before, no surprises. Once this one's done, I'm gonna get an accurate measurement on the width of that cut. Like I said, I know this cutter was reground. It was supposed to be 5/8 inch wide. I know it's smaller than that. And then we'll figure up how much more we need to move the table over to get the proper width, and we'll make one final cut, and that'll be at the full depth, just taking off a little bit over on this side over here. All right, we'll bring you back. This is the final pass, and as you can see, we're just nibbling a little corner out there, making it a little bit wider. It's 70 thousandths of an inch is what I had to move the cutter over to get to the proper width. So again, one more pass through here, and I think we'll have this job knocked out, at least this part of it. So we'll bring you back here in a bit. And here we come, right out the end. We'll let that finish getting down through the center. And I think we will have our mill slotted in there just like we need. which will be step one in this project. We've still got a lot of work to do, but we'll probably wrap this one up after this shot here. Like we said earlier, we could have used a cutter that was the exact right width, and I think now that I've done this, if this was a production job, I would have no problem running the next ones at full depth, but we don't have any more to cut, so not gonna have to do that. This is typically how you would set up a production job, is you would kind of ease into it, get everything set like you wanted. If everything was cutting good, the next one I cut, I would cut at full depth. And I would probably also increase my RPMs and my feed rate, you know, periodically, just to kind of see what I can get away with and see what it's going to work good. I think we can go with a little bit faster in both RPMs and feed, but we are where we need to be. All right, guys, we're done with this cut. So here's the finished product. We got our nice groove in there. I have checked the dimensions and everything checks out just exactly what we dialed in. The depth, the width, everything looks great. You know, I will say, you know, we got a little bit more on one side than the other, but what's important is this back jaw. This is the good side. This is the side that was down on this jaw. It's not worn, so I'm feel good that that's a good measurement. The height on here varies wildly. It's you can tell it's been beat on, ground on, everything else. That's probably the original thickness there. It's just going to stick up a little bit high on the vise, which is normal. So worst case, I may get with and make sure if we need to deck a little bit of material off the top of that, but I think that's going to be the right height for that as well. You can kind of see them end to end here. So, well, there we go, guys. Some horizontal milling action out here in the machine shop. I hope you guys enjoy doing that. I always enjoy using the Kearney Trekker horizontal milling machine. Back when I worked in a machine shop in the late 1980s, did a lot of production work using horizontal mill, and it's just always been one of my favorite machines to work with, even though most people consider them to be obsolete in today's world of CNC and big five-axis mills and what have you. In a job shop, I think they perform a valuable service, and I just enjoy using mine, like I said. This job could have just as easily been done over on the vertical milling machine with an end mill, but again, I like using that horizontal mill. And I have no doubt that in a production setting, at least with a conventional vertical mill and a conventional horizontal mill, once it's set up with the right cutter, one pass through there, it'd probably be more efficient to do this job on a horizontal mill than it would be on a vertical mill machine. In today's CNC world, all bets are off. But we're doing it the old school way here. There you go, guys. That is going to be a wrap. As always, thank you so much for watching. Please subscribe to the channel if you haven't already. Thumbs up, comments, greatly appreciated. Those thumbs up when you like these videos, it really helps the analytics on the channel. Please do that if you can. Hit that bell icon up there to get notifications when new videos are posted. And as always, a big thank you to my Patreon supporters and other supporters of the site. Greatly appreciate everything you guys do. Couldn't do all this work without you. And with that, guys, we're going to sign off. As always, thanks for watching.